quantum computing, what it is, why it matters, and the potential future applications of this groundbreaking technology. Let's get started. Quantum computing is a type of computation that harnesses the phenomena of quantum mechanics to process information. Unlike classical computers, which use bits as their smallest unit of data, represented as a 0 or 1, quantum computers use quantum bits, or qubits. A qubit can be both 0 and 1 at the same time, thanks to a property known as superposition. This allows quantum computers to process a vast number of possibilities all at once. But why does quantum computing matter? Well, the power of quantum computing could revolutionize numerous fields. From cryptography, where quantum computers could crack codes unbreakable by classical computers, to complex simulations in physics and chemistry, the potential is enormous. Quantum computing could also optimize complex systems, such as traffic flow in cities or supply chain logistics. Here are some reasons why quantum computing is important. Complex problem solving. Quantum computers excel at complex problem solving. The unique properties of qubits let them solve certain classes of problems faster and more efficiently than traditional computers. For example, modeling the behavior of individual atoms in a molecule is a complex problem because of all the different electrons interacting with one another. Combinatorics. Digital computing has limitations in regards to an important category of calculation called combinatorics, in which the order of data is important to the optimal solution. These complex, iterative calculations can take even the fastest computers a long time to process. Quantum computers have the potential to perform combinatorics and other calculations much faster. Quantum simulation. Quantum computers can model complex molecules, which may eventually help reduce development time for chemical and pharmaceutical companies. Optimization and search. Every industry relies in one way or another on optimization. Quantum computers can significantly improve these processes. Let's now imagine some hypothetical uses for quantum computing. Here are some hypothetical uses for quantum computing. Quantum computers could far surpass conventional ones in data pattern recognition, which would significantly enhance the capabilities of artificial intelligence. Quantum computers could be used to simulate molecular-level quantum mechanics, which could lead to the development of more efficient batteries. Quantum computing could help optimize the process of fertilization, leading to cleaner and more efficient methods. Quantum computers could be used to crack encryption, thereby revolutionizing the field of cybersecurity. Quantum computers could accelerate drug discovery by simulating the behavior of molecules, which could reduce the time and cost of developing new drugs. These computers could be used to discover new electronic materials, leading to advancements in technology. They could be used to optimize financial transactions and improve decision-making in finance. Hypothetically, quantum computers could optimize the process of solar energy capture, leading to more efficient use of solar power. Quantum computers could be used to optimize traffic flow, reducing congestion and improving transportation efficiency. Quantum computers could improve weather forecasting and climate modeling, which could help us better understand and mitigate the effects of climate change. These are just a few examples. The potential applications of quantum computing are vast and could extend to many other fields. However, it's important to note that while these applications are promising, quantum computing is still a developing field, and these applications remain largely theoretical at this point. The future of quantum computing is incredibly exciting. While we're still in the early stages of this technology, progress is being made every day. Companies like IBM, Google, and Microsoft are investing heavily in quantum computing research. In the future, we could see quantum computers solving problems that are currently impossible for classical computers to handle. In conclusion, while quantum computing is a complex and challenging field, its potential to transform our world is undeniable. As we continue to explore and understand this technology, who knows what incredible discoveries await us? Thank you for joining us on this journey into the future of quantum computing. Don't forget to like, share, and subscribe for more exciting tech content. Until next time.